Good evening. And I think we're all tired because of all the great presentations. You can see a team enjoying from the morning, and very glad to be here. And it's a very special year for me because that is a picture in Jacksonville, Florida, and you can see the date is February 27, 2014, when the version of Presto was 0.65, and I conducted my first meetup there, and it's exactly 10 years. So great to be here and working with a lot of great people all along the way. Ali, Tim, everybody here, right? So excited. Of course, I'm a Presto fan, a die-hard Presto fan. It has given me bread and butter for the last 10 years, lot of implementations across the globe. And it has helped me to write a lot of articles related with building data lakes. And recently I started aggregating my solution along with Min.io, which is an open source but AGPL licensed object store, which is cloud agnostic. So I can just combine all the storage into a Min.io bucket, and then I can read and create all the data from that particular bucket, and making sure that if you are implementing Min.io, you are not having too much network latency so that the performance of your Presto queries and everything is becoming very fast. So coming to the topic, data is proliferating, as all of us know, and along with that, problems are proliferating, and at the same time, opportunities as well are proliferating. And any data lake implementation you look, the skeleton, if you see, is this basically. You have all kinds of surrounding characteristics, but most importantly, finally you are going to store the data in some format, and that is a problem. And this is a big problem that I faced in any implementations that I have done. That somebody tells that I'm storing as ORC, optimized raw columnar format. Somebody says that I store as Parquet or maybe CSV file, right? And then suddenly the requirement comes and telling that, in my dashboard, I want very fast indexing. I will be looking for an open search kind of indexing for my data so that I can create a Kibana dashboard very fast out of it, and I don't have to worry about this Parquet and all. So in many places, the problem what is happening is that they all support, okay, all major architecture frameworks. If you take, they are all pertaining to a particular format, and that particular format is not sufficient and not enough for catering to all the business needs. That's why we came up with a new idea. In our data lake architecture, I will go for polyglot persistence, following Martin Fowler's terminology. Polyglot persistence means that depending upon the business use case, let us select the format that is required, not typically tying to a particular format, and let the ingestion mechanism decide, depending upon what you would like to do, the format, what is needed. Today morning on the keynote, the panel meeting, I have heard that somebody was telling that a lot of formats is a problem. Not necessarily. I tend to differ to that particular point. Why? Because formats are meant for different purposes, and we need to store it in that way. That's why we created this architecture, very stable for the last decade, running at many major places: healthcare, logistics, transportation, AI companies, etc. We created a layer which is called the connect layer on the top, connect to any data source. Then we use DBCM or Spark or Flink or those kind of things in order to capture the data. We integrate it through an Airflow-based UI to schedule it. We add some metadata while ingesting, like from where the data come from, where the data is going, what time the data came from, etc. so that we got the metadata also when we are ingesting it. And then we got this particular persistence polyglot layer, which is layer 7. So rather than not sticking to a particular format, we are telling that, okay, if I want arrow, I will store it as an arrow format. If I want open search, yes, Elasticsearch or OpenSearch, we will use it. If we want star tree indexing, aggregation at a very high level, maybe we will use Pino. And all these are supported by the object storage. Why? Because all these formats can be stored into an S3 bucket, and then I can have that cloud agnostic S3 events and everything that can be configured onto these MinIOs or Cephs of the world. So far, very good. And the persistence layer is working very well. Depending upon the different scenarios, we will use what format is required. But now, the things are changing. Yes, there was AI. There were RNNs, convolutional neural networks. We used AI so much before. But what RNNs or CNNs could not do, this paper changed the world. I'm sure you might have seen that. Attention is all you need. They came up with that particular transformer architecture, a feed-forward network written by the Googlers and others in the group, and a whole lot of opportunities started coming in. The GPTs of the world started proliferating. Models, bidirectional encoder representation from transformers or BERTs. And you suddenly started thinking about how can I make AI, everywhere AI is coming in. Even the people who are telling that I want to do to AI, they don't know what to do for making the company to be AIized. Well, it needs now a new kind of format. Again, the problem is we need one more format now. And that's where that polyglot persistence layer is becoming very much relevant. So what we can do? We will go into another kind of representation of data, which is allowing you to have massive search, contextual searches on the data set. And that's where the vector databases is coming in. And if you are not aware of what is meant by an embedding, it is nothing but a mathematical, multidimensional representation of data. And that data, when it is represented, it will be in a multidimensional, beyond our imagination, hundreds, thousands, and millions of dimensions, goes inside and then gets stored. And what happens is that whenever you are storing it, it will show you that when the searches are happening, which search is happening, which are the nearest searches, etc., etc. The contextual window that was limited in an RNN was getting eliminated. Now it is becoming infinite with the transformer architecture paper that I have mentioned to you. So we need a better representation, and also the importance of Presto is going to be better than ever. Why? Now, if you ask GPT a question, it is going to give you an answer till using the data that is available to it and till when that particular model was created, correct? For example, if I ask today's data, or if I ask my organization's data, if I ask a question to ChatGPT or any of the transformer network, I'm not going to get the answer. Why? It doesn't know about the data. That's why now you need all your organizational data to be part of this particular model, and then you should be able to get that same result, just like how ChatGPT is giving for older trained data. Which means that you are going to have something called retrieval augmented generation from your custom data. And then you are going to use the context, and then you are going to get the result. And you know very well, if you want that data from your organization and all data you want to pull in, what will be fitting there? It's Presto. So by keeping that particular rail, your RAG generation is going to be ultimately powerful, provided you have the ability to store the data in vector format as well. So everything is now coming together. So if you look at a basic architecture of how an AI-based prompt engineering is going to work, right? You have the data, and you are converting the data into vectors, and then you are going to add a semantic index, and then you are going to store it. Now, even though my topic is related with the LanceDB as an example, I'm not related with the LanceDB at all. Any of the vector databases that you can see, not only LanceDB. So we should be able to store that particular data. So understand the architecture earlier I have mentioned to you. The polyglot persistence layer is now going to get expanded to adopt or add additional storage formats, which can be any of these. And then the user is going to ask any question. It will be converted into an embedding API, and then you are going to search in that particular vector database. Boom, you got the answer. So your custom data is now part of that particular framework, provided you have the ability to store it into a vector format. So the architecture is going to be changed. All formats, everything is good. Now I want to add vector embeddings into my polyglot persistence layer. And when we are adding it, the architecture is getting a little bit of change where you are going to get the vector embeddings, and now the question is, you have got that Presto, and I have intentionally written it as Presto plus platform. Why? Because we have added some Ranger integration and some additional security, additional audit plugins, etc. onto Presto. That's why I put it as Presto plus, but it's Presto. But now you need to query it, and you need to get the data of that particular vector embedding, and SQL is not always a good choice for querying a vector database. And just now you might have heard the LanceDB presentation where they are now creating the create table as, but select star is not yet available. So one approach is, of course, creating your traditional LanceDB connector. Take that 4 modules or Kafka module and then just replicate it, understand how the slices is working, just to go to each and every slice and then get the data, aggregate it, you create a connector. But is there a better way? If I create a connector tomorrow, if suppose Milvis is coming or if Face is coming, then what I should do? I should again create the connectors, which is pertaining to what Tim has mentioned in the morning. Connectors are difficult. Connectors should be automated. We should not be building connectors each and every time when a new format or a database is coming. We may need to have a new generic approach by which we will be able to do it. And the way that we have done that is, again, Tim mentioned it in the future implementations of C++ as well as in the normal Java-based Presto. Create an Aeroflight server. That Aeroflight server will be running in a separate runtime, and from Presto, create a gRPC Aeroflight connector so that your code, whether it is written in C, C++, Ruby, Python, that code will be running on its own runtime, not related with the Presto at all. It is running standalone, and Presto is here. You are going to connect it using the Aeroflight server protocol. Done. If you are doing that, then one runtime will be running LanceDB using Python, another might be running Milvis, another might be running Pinocon, another might be running Face. And I can query from Presto all the 4 with 4 ports and then aggregate the result, and I can check which one is giving me the accurate result. I can play with the world of AI. Any GenAI application is in our fingertips because the application is running in its own time. So how will you see all these things, right? Well, go to the Python, and I just used Python for now. That's my flight server code. In the flight server, there is a concept called flights. Flights is nothing but the functions. So you are going to write the functions inside the flights. Look, these are all my functions. And each function is a Python code. So this code may be your LanceDB reading AI-based code. This may be a Milvus-based vector-based code. This might be a ChatGPT API-based code. So you have created this code, and then you called these codes by just a name. And from Presto, when you are connecting it, these functions are available to you as tables. So you just query the table, that function will get invoked, and you are going to get the result. And that is going to change everything, correct? And when I start the flight server here, as you can see here, the flight server, an asterisk shows that it is being served, and I have got two methods here, and the method that I am using is, just for an example, a LanceDB YouTube video transcript, a beautiful application which is showing you the power of YouTube transcript search, an AI-based code. So I just took that particular code, and I am running it in on runtime. It's a Python code, not having any relation with Presto. And it is running in independent runtime. And then we got our favorite server running. Please don't worry about that prompt. I just changed the prompt for my custom use. It's a Presto prompt. And then I'm going to give me all the tables. Show tables from GenAI.default. GenAI is my catalog. Default is the schema. GenAI.default. How many functions you have seen in the code? Again, let's see how many functions are there in that code. So if you look at the code that I have executed, I have written here simple and GenAI with Presto. Simple and GenAI with Presto. There are two functions I have written here, and please look at what I am getting when I am getting the result of show tables from GenAI.default. GenAI with Presto and simple. And remember that GenAI with Presto is invoking a LanceDB code, and simple is just for my testing. And then you are going to execute the code from GenAI.presto. It is going to go to the YouTube transcripts using LanceDB. Internally, it is calling ChatGPT for embeddings, and then it is going to give you the result. You can use NLI with multiple negative ranking laws or STS with cosine similarity. And that is the answer to the query that I have asked in this particular code base, which training method I should be using for sentence transformers when I only have pairs of related sentences. What you have basically done is, using the flight server, you were able to call, and then you have to get the result. And now you are not tied up with one vector database. If you are able to implement multiple vector databases, you can easily start each of them. You look at this code. I am just starting it in a port, and I will show you my catalog file. Control D. And if I look at my catalog file server, etc/catalog/genai.properties, you will see that I have created the Sigma flight connector, which is arrow flight connector, and then I'm just connecting to the port. So if I run another port with Milvus, another port with Pinocon, imagine just by a single query, you will be able to aggregate the result from multitude of vector databases, combine the data, do the RAG generation, and then so on and so forth. So GenAI applications are becoming more easy by using this particular approach. Anything that you want to do, just run it in runtime. And I just showed you the Python example. Remember that flight server is available in Ruby, Java, C, C++, whichever language you can think of. All right, so coming back to the presentation. Am I on time? Yeah. We have done something additional also, just for your information. whatever architecture I have shown you, the user need not write a single line of code. You might have seen that create, compose, contain, all these words there, right? We created a UI so that when the user is selecting, the UI is going to ask for what type of applications you are ingesting the data. If quick dashboarding is your answer, automatically the system will select OpenSearch as the persistence layer. If you say GenAI as your use case, it will automatically select vector database as the storage. So we made that intelligence by creating a UI, and all the components are aggregated together into an ecosystem controlled by Kubernetes pods. Auto-scalable, cloud agnostic. We don't use EKS, we don't use AKS, we don't use Glacier, we don't use Azure S3. We use MinIO. We package it together, which makes us to deploy it on bare metal. For me, cloud is not for services. Cloud is only for metal. I don't want to rely on black boxes, a SageMaker or a cognitive science application where I don't know what is going on. Give me 3 EC2 machines or give me 3 virtual machines. We will deploy it completely open sourced, Presto, components, everything, all aggregated to work together, reduce the cost, improve the innovation, and get the data and create the value that you need. Thank you very much for listening. Any questions? Yes, please. Uh-huh. Oh, of course, of course, of course. You can. Yes, so you can write a Python code. You can just make an API call, maybe using a GraphQL or whatever it is, and then maybe you will be using a Neo4j based database, and then you are going to just register that function into the flight server and then query it. That solves how to query graph databases with Presto. So yes, you are getting the idea, right? So anything, if you want more or anything, these slides will be available, of course, in your recordings and everything. So that's my LinkedIn and that's my email. So please feel free to reach. I have not updated it. There are a little bit of cleanup that is needed because I was working on completing this before this particular presentation. Some testing and some things that I need to modify in the code base. After that, I will be updating it and requesting for a PR. And we'll be pushing it. If suppose you want to try it before or you want to connect with me, feel free to write to me. Thank you very much. Let's head to the next one. Bye-bye.